let's look at what to do when we're working with angles that have numbers attached to them, not theta, alpha, etc. So in this one, I want us to just have a look at the example number A. Cos 290 degrees multiplied by cosine of negative 10 degrees plus cosine of 160 times sine of 550. So if I do my little cos diagram, then I can identify where everyone is, because I can put my angles in there: 0, 90, 180, 270, and 360. I use this to identify my quadrants. So cosine of 290 is bigger than 270, smaller than 360. This is in quadrant 4. Okay. Cos of negative 10. Now remember how we do this. Negative 10, you're going to start at 0 and you're going to go in the opposite direction. So it's going to be somewhere in the 4th quadrant. Okay, cos of 160. 160 is less than 180, so it's over here somewhere in the 2nd quadrant. And cos of 550. Now on this one, you need to basically go around and say, okay, one full circle is 360 degrees, so it's 360 plus, so in essence what you're going to have to do is you're going to have to use your calculator and say 550 minus 360, and that gives us 190. So you have 550 and 190. Okay, and once we've done that, 190 is more than 180, so that means it's over here in the 3rd quadrant. So this is quadrant 3. So the first thing we need to know is where is everybody, right? Okay, now we're going to deal with them. What we're going to do is we are going to rewrite them as our reduction or our cofunctions. But remember, I always say to you, if you have a choice, use reduction first. So remember over here, this is going to be 180 plus theta, 180 minus theta. 360 minus theta, or just theta, 360 minus theta. Sorry, the top one is plus. Okay, so now we need to choose. For cosine of 290, we are in quadrant number 4. Now in quadrant number 4, we are closer to 360 than we are to 180, because we're over here, right? So we are going to use this line to make 290 degrees. And in order to do that, we are going to say this angle is cosine. Now what we're going to do, let me get the calculator. So to get the angle, remember we want an answer that equals 290. So you're going to say 360 minus 290 gives us 70 degrees. In other words, 360 minus 70 gives us 290. The second line is the line that we want. 290 must be at the bottom, because 290 is what we're wanting to replace. Whatever we're writing must equal 290. So if the bottom says 290, we're going to write the top line, all of it. 290 is 360 minus 70 degrees. All of it gets written down. Okay, let's do cosine of negative 10 degrees. So that negative 10 degrees, we are sitting in quadrant number 4. So let's leave it like that right now. And we'll come back to it when we are reducing, because right now we're just getting our quadrants straight. So we're fine over there. Plus cosine of 160. 160 is closest to 180, right? So that's going to be 180 minus 20 equals 160. 160 is equal to 180 minus 20 degrees. And then that sine. Now what happened with the sine that we now went a full revolution? What you're going to do is you're going to ignore this and ignore this. This is now sine of 190 degrees. And 190 is in quadrant number 3, we said. So now we're sitting with 180 plus 10 degrees gives us 190. So this is sine of 180 plus 10 degrees. Brilliant. So we've now managed to take our single identified angles. We figured out what quadrant they're in, and then we managed to split them into an addition or subtraction sum that has the reduction angles 180 or 360 attached to them. Beautiful. Now that we've done that, we can now reduce and remove the angles that we have. So remember, we're sitting with cos of 70 degrees. What did we do? We took this and that down. Now the next question that we have is, because it is in quadrant number 4, cos is positive. So this is positive cos of 70 degrees because it's in quadrant 4. I'm going to put it in brackets because I want to multiply it with the next one. Now, cos of negative 10 degrees. Negative 10 degrees is in quadrant number 4. We are going to sit with cos of 10 degrees because we're keeping those two pieces. Now, the question is positive or negative. Cos is positive in quadrant number 4. So we have cos 70 times cos 10. Okay, beautiful. Add to that. Again, you're keeping those two pieces. And on this one, we're keeping those two pieces. So here we've got cos of 20 multiplied by sine of 10. And the only thing we need to add here is the sine. So cos of 180, cos of 180 minus 20 is in quadrant number 2. Sine is positive, cos is negative. Sine of 180 plus 10 is in quadrant number 3. Tan is positive, sine is negative. That's brilliant. So this is where we are. On our next line, we are going to multiply our signs out, basically. The only thing that we're going to drop are the signs. And the reason is we're going to keep them separate. You don't know how to multiply cos 70 with cos 10. So we're going to keep it as cos 70 times cos 10 plus, and why are we saying plus? We're saying plus because minus and minus make plus. Plus cos 20 times sine 10. Beautiful. All right. Now the question is, given this information, do you have a highest common factor by any chance? Or is this something that you can reduce and identify? Okay, if we think about our compound angles, we have sine is equal to sine cos cos sine, and we have cos, which is equal to cos cos sine sine. Now, I have cos 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 sine, which is not what I want. What I would want, if I'm looking at my pattern, you can look in your book, is if I look at the 4 items I have, this one is wrong. I would like it to say cos cos sine sine. So here's a question. Can you convert cos of 20 into something else? And the answer is yes. So according to our co-functions, cos of 20 is going to be equal to sine, or this cos of 20 is equal to cos of 90 degrees minus 70. Cos of 20, just stick with me, it makes sense to you, right? So 20 degrees is equal to 90 minus 70. It's the same thing we've been doing with the reduction formula. So we've changed this 20 and we've written it as 90 minus 70. And we can now change that 90 minus 70, which is in quadrant 1. Quadrant 1, it remains positive. Now it becomes sine of 70 degrees. So now I can rewrite this as cos 70 cos 10 plus sine 70 sine 10, and that in itself is cos cos sine sine. Whoop-de-doo, this is brilliant. We now manage to prove cos of 70 plus, no, because the sign changes, right? If it is cosine, the sign will always be different. So it is minus 10, which means we're sitting with cos of 60 degrees, which in itself is a special angle. And if you go to your special angle triangle, we've got 345, 60, and then 90, and this will be the, remember, cos is x over r, so y is going to be equal to 1 over 2. Again, you can always check on your calculator. So cosine of 60 degrees will give you a half, and if you press SD, you will get. So if you have your special angles, you can actually check for your fraction on your calculator. Special angle, cos of 60 degrees. There we go. This is example A.